Hi everyone, thank you for joining our webinar. I'm Ade and I'll be hosting this session. Today we'll focus on our Adsorbent media Puratech for drinking water applications, and our Sales and Business Development Manager, Ryan Adams, will be leading today's presentation. Just a few housekeeping notes. The session will be recorded and shared with all attendees afterwards, so if you have to drop off midway through, that's absolutely fine. And feel free to use the Q&A chat function to submit your questions, and we'll go through them all at the end. So Ryan, over to you.
Great. Thanks, Ade. So just to check, the presentation's up and looking
Yeah,
good.
we can see it.
Fantastic. Awesome. Thank you everybody for joining today, whether it's the end of your day if you're in Europe, or almost lunchtime here. I'm guessing between you and lunch. I'm here on the East Coast. We're just starting your day on the West Coast or wherever you may be in the globe. So yeah, like Ade mentioned, we're going to talk about our absorbent media for drinking water applications, and looking forward to discussing that with you. A little bit about myself. So my name's Ryan Adams. I am the Sales and Business Development Manager here at Puraffinity. Been here for roughly 2 years. December was 2 years, so a little over 2 years here. Based in Orlando, Florida. So sunny Florida down here. And roughly 10 years or so in the water treatment industry. So I joined at the end of 2015, so going into 2016 with a major manufacturer on the POE and POU side, and I've kind of been on that side ever since I joined the water treatment industry. So my focus has always been on the POE, POU, RO for the residential commercial side of the business, focusing on the dealer side, so the frontline sales on the dealer side across the Southeast here, the distributor side and OEM sales side. So much more of the sales side of the business than the extremely technical side of the business. So like to collaborate with my colleagues in engineering or PD if there's stuff that goes way over my head, but that's why they're here. So I'm happy to talk with you guys today about the drinking water side of the business, specifically the POE side of the business. You can see there in my email and my work cell phone there. If you are internationally, it's the US country code 001. So I will have that at the end as well, in case you don't get a chance to write down here. And as Ade mentioned, it's recorded as well. So we're happy to answer any questions you may think of after this webinar, or just general inquiries regarding anything water treatment related. We're happy to discuss, either myself or some colleagues around the globe. So a little bit about Puraffinity. If you're unfamiliar with Puraffinity, Puraffinity is based in London, on the west side of London there. And it's basically a company specifically dedicated for PFAS. It was spun out of academia in roughly 10 years or so ago. And as you can see there, and kind of who we are. It's a sustainable technology company specializing in design, manufacture, and supply of smart absorbent materials for PFAS captures. So we are specifically focused on PFAS. And with that, we were looking to improve human environmental health, effectively removing PFAS from water. So with that comes our product. It's a functionalized activated alumina, and I'll go into this a little more here shortly, specifically designed for removal of PFAS from contaminated water. So it is all we focus on, unlike legacy products, which focus on removing numerous different contaminants. We are specifically focused on PFAS. So the current landscape, as a lot of you on this call are probably very familiar with what the current landscape is around the globe, but I'm just going to touch on it here for a second. Map of the U.S. here. If you're unfamiliar with EWG, they do a lot of work, and we pulled this map from them there, where you can see, around the country in the U.S. here, where it's above the proposed limit, some that are right below it, military sites and other sites. You could easily have a map like this for Europe as well. But basically it stems from decades of neglect across the manufacturing industry, as you can see here in the States here, for the last 70 years or so. So obviously PFAS in our air, water, soil, wildlife, fish, even our blood, it is everywhere, due to those manufacturers, roughly 70 years ago. So With that, we have changing federal regulations. We have the previous administration, Biden administration, set some really low limits that they wanted the country to get down to. The Trump administration has rolled some of those back, but kept a few. And then with that, you have upcoming or existing state regulations that are either sticking to going below the Trump limit, where Trump moved them back up to that administration, or going all the way down to where as low as the Biden administration um, wanted to go to as well. So, with that, you also have some testing capability issues. There's, if you go to a lot of conventions, you're seeing companies that are promoting their testing capabilities, but getting down to those super low limits to detect PFAS all the way that low is very difficult to do, and there's not a lot of people doing it. So, and with that comes it's very expensive as well. So, that's the little snapshot of the overview of the kind of PFAS landscape. Here in the States, similar things in Europe. You have change in regulations there as well for country by country, and then the overarching EU. It's
Sorry, everyone. Ryan
um,
did say he was having some technical difficulty. Oh, he's back again.
oh, I should have mentioned
Yeah.
my internet never has issues ever, and it just something was going on immediately right before this, so I apologize. Um, so our business to business sales of the media offered as bulk. Supply pre-filled cartridges and treatment skids, more so for the environmental remediation side of the business. AFFF, things of that nature. My European colleagues have been doing a lot of work with that over there, but definitely offered as bulk. And then we have some skids for the other industries as well outside of the POE space. The G400 Plus is an alumina substrate, so patented surface coating creates a targeted material for capturing specifically PFAS. So we are dedicated to specifically capture PFAS, where a lot of legacy products have um, competing ions that they are targeting as well. So you can see the size there: 0.5 millimeter diameter, granular material, density roughly zero point 0.8 kilos a liter. And with that, we can reduce footprint over existing products, enabling a much more compact and easily serviceable solution. So with that, it's also compatible with different PFAS destruction technologies. There are companies, as many on this call are probably familiar with, that are doing a variety of different things. And we've partnered with them, testing and making sure that our media would be compatible with them. And then there's also always, as many are familiar with, incineration, where you can just burn it. So with that being said, the one question that always comes up: are you NSF 61 certified for drinking water? We can proudly say that yes, we are now. So G400 Plus Adsorbent Media has been certified by IAPMO for NSF 61 and 372 standards for point of entry and water treatment plant applications. So we are proud to finally say it's one of the reasons we are hosting this call, to kind of keep announcing it to the world that on the drinking water side, we're open for business and continuously looking to pursue projects and products to partner with manufacturers and around the globe. So with that, major milestone and hurdle for us on the drinking water side of the business, and full steam ahead from here with regards to that. So a little bit about the cost of ownership for the media. So you can see up to 50% reduction in ownership versus legacy products of Ion Exchange and GAC. That's going to vary depending on project and everything, but you can see significant savings overall. With that, with our media, those rapid kinetics that allow for much shorter empty bag contact times. So where you have the POE side of the business, where you have water flowing through rather fast. It's the empty bit contact times is not an issue for us. So I have some data in a few slides here that I'll kind of go over that a little more, but those rapid kinetics allow us to remove it quite fast. And with that comes operational longevity, significantly more than ion exchange or GAC, and then a broad spectrum of PFAS removal to meet the compliance. So where we can work on short chain and long chain makes a big difference where the legacy products have their issues, especially with short chain. And then you can see a reduction on the CO2 compared to the industry standards, and as I mentioned before, much smaller compact insulation, which I'm going to go into here in a second. With that comes reduction in CapEx and OpEx across the board. So let's discuss current products and future envisioned products as well. So existing PFAS product offerings, they're using legacy products they were always designed for other applications. So giant carbon tanks, um, softening tanks with, you see a software on a brine tank there. On the POE space, big blue housing, but 20-inch, 10-inch big blue housings for filtration going into the home. Whatever it may be, you have longer contact times, much bigger system footprints. You're replacing that media much more frequently. When it comes to carbon, competitive absorption, and then you can lead to fouling issues as well. So the current PFAS product offerings outside of novel technologies has just been legacy products. So where you troubles with space, on the POE side, if you're looking to put a system up in the Northeast, Midwest, Northwest in a basement, you can be confined on space. And where I live in Florida here, we have a lot of softeners and filtration that's on the outside of homes. Depending on the home situation, you can be confined for space on the side or in garages. So we'll put them in garages here as well. We obviously don't have basements here in the majority of Florida. So you can be confined on space. So shrinking that footprint really can make a big difference. And we believe that's where shrinking it significantly, that's where Purafinity's PureTech G400 Plus can come into play. So what we envision on the future of the POE products. So our media is specifically designed for PFAS removal. So if you think outside the box of what your existing product offering is, whether it's you're using softener tanks, carbon tanks, 10 by 54s, 13 by 54s, whatever it may be, you start to think outside the box on how you can incorporate a much smaller offering into that, whether it's a treatment train or a dedicated PFAS offering. That's what we're looking to partner with people around. So if you think about how multiple technologies can solve numerous needs. So if you're putting it in a home and you want the softener to, if they're on city water and you want the softener to soften the water in the home, so they have that nice silky hair, and then also you run a product with ours after it as well to clean up all the PFAS. Kind of working that treatment train here. So I put some pictures up here. A lot of people in the POE space will be familiar with the big blue housings on the top right there. 20-inch and 10-inch housings. Whether it's using standard cartridges, refillable cartridges. We're looking to partner around how we can incorporate the media into the point of entry application to the home there. You can see a smaller tank next to it there with a auto control valve on a skid. That was for a project over in Europe. Put it in here to kind of give you an idea, just kind of tank size of what we used over there for a more industrial project. You think about it on the POE side, how we can go even much smaller. So I put some tanks on the bottom here. My thing I wanted to point out is if you think along the lines of more so like a softener tank size for RVs. So they're much smaller, much tinier. People that want soft water on a recreational vehicle, they use these super tiny tanks. We've been in discussions with someone more recently on the POE side that's looking to do the 8x18 tanks. So think really, really small compared to what you maybe used to before. And with that comes much less media, and then much less cost, where you can shrink that CapEx and OpEx over the life of the media. So We can shrink that footprint, much shorter contact times, 30, 45, say less than a minute, basically. The backwash capable, so if you put a control valve on them, you can absolutely set it up to backwash, rinse off the media a little bit, send it to drain, and then back into service. And then also, I mentioned shrink CapEx and OpEx there, and then having a minimal competing contaminants. That's there's not a lot that at all that really competes with the media. So I mentioned earlier, it is designed to target PFAS, and it does a very good job of doing so. So when it comes to PFAS products on the future on the POE side, think outside the box and think how we can shrink and really minimize a footprint while producing longevity across the board. So we're welcome to having discussions with that myself, my colleague, who was also named Ryan, in the States here. More so on the industrial side, just thinking smaller. So anybody here who's thinking municipal drinking water and stuff, so we can shrink it, a footprint, and the cost significantly. So a little bit about testing, a little data, which I'm sure a lot of people are interested in. We did some external testing, performance testing with a point of entry manufacturer, trying to reach breakthrough at various empty bed contact times. There was some column testing. So we did 35 or 30 and 45 seconds. You can see the volume of media they used there. And they basically ended up stopping the test because it was taking forever and not breaking through. So I think the equivalent there is roughly 30,000 bed volumes that saw no breakthrough, and we're still could have been going on for quite a while. So the breakthrough threshold was 20 ppt of total PFAS. So they cut it off before the end of it there. So with that, we saw fantastic performance, and we are continuing discussions with them on through some other projects as well. But as you can see, minimal contact times and the point of entry side of the space that makes a big difference. These next two data points and charts we've shown, I believe, I don't know if it was Jamie's presentation or somebody else's, but I think it's important to bring up. And we did some testing using NSF 42 and 53 conditions and looking at breakthrough concentrations versus GAC and ion exchange. And so you can see the volume of water treated there. We were up there around 60,000, and ion exchange a little less than 10, and GAC much lower. So we've done a lot of third-party validation, whether it be or externally and validation internally. You can see there Colorado School of Mines, TZW, which is in Germany, and then Heritage Group, extremely large environmental services group here in North America as well. So we've extensively tested it to really prove that it can prove those CapEx and OpEx savings, and then how we can shrink these footprints and still give you superior performance. So for NSF 53 PFAS removal performance, so you can see a simulation here as well for a variety of different contact times for total PFAS. And you can see the influence there as well in the bed volumes, the significant bed volumes treated before breakthrough of the total PFAS concentration, 20 ppt. With that, at these low contact times. So you can see the purple chart, 15 seconds, extremely low, and then 30 and 45, pushing over 40,000 bed volumes. That really does highlight its capability for POE, and it says POU there, but POE space, enabling compact systems, much longer lifespan, shrinking the footprint across the board. And with that, you can shrink your cost and really drive revenue and performance for your customers, whether it be homeowners, commercial business, whatever it may be. And then a direct comparison against ion exchange here as well. We compared it to a lead ion exchange resin. A lot of you could probably guess what that is. Against G4 or PureTech media, and same thing, 20 ppt. You can see the influent there, 1300 ppt influent of some of those 4 PFAS, 30 seconds contact time, like for like. I realize that like for like, ion exchange normally would have longer contacts, but using this to represent that shorter contact time how much more we can treat, pushing, 90,000 throughput in bed volumes there as well, compared to 40-ish for the ion exchange. So with what we like to really allow all this data to represent is how going, against the legacy products, there's obviously a place for them. Um, but think about it when looking to treat this PFAS issue globally, it's going to take a lot of different technologies and it's take a lot of different solutions. So we're looking to be a part of those solutions. And when considering projects or products you're looking to develop or whatever it may be, we'd love to be in that discussion and test and talk with you on how we can really incorporate it into either existing offering or create a whole new product offering. And with that, just in summary here, um, opportunity to reduce the total cost of ownership through reduced material, longer lifespan, rapid kinetics, low contact times, third-party validation. We're going to be continuing to do third-party validation. We're going to continue to put out case studies, whether it be on the industrial, environmental remediation, POE side, whatever it may be, as we get data, putting it out there. And as regulations grow and change, behind the scenes, the PD team constantly working on further work for things to treat and whether it be the ultra short chain stuff or whatever it may be, we're constantly looking at future products many years down the road as well. And lastly here, I'll leave this up here while we filter through some questions. But you see my email there. I'm happy to field any questions, comments, concerns that you may think of after this call or after this webinar, or feel free to call me. That's my work cell phone there. Happy to take a call, set something up with you and your team, and kind of go from there and see what we can create on, especially on my side, on the POE side, some municipal drinking water. We'll get my colleague Ryan Denny's involved as well. So really want to thank you for joining us today, and open to whatever questions you may have, Adi.
Yes, so we have some questions. The first one is, what is done with the material when it is saturated with PFAS? Is PureTech G400 Plus regenerable?
Good question. It in its current state is not regenerable. That's the short answer of that. If in the States here, if you look at the regulations, we advise to just currently incinerating it. The way the laws are set up now, just like with ion exchange resin and carbon, technically you can landfill it. We don't like to advise against it. We did say incinerate it, or there's a lot of handful of different companies that are doing destruction technologies that can help dispose of it as well. But not regenerable currently. Maybe one day down the road, but no.
How does reduced media volume translate into system footprint and maintenance advantages?
Yep. So reduce. So if you think about like if you had an existing footprint with a 13 by 54 carbon tank or something along those lines, 1252 or whatever it may be, you can shrink that down to a 8 by 18 tank where you have a fifth of a cube of media versus an enormous 1354 carbon tank. So with that, you can significantly shrink. Tanks are expensive. You can shrink the cost from the cost of a tank like that versus the cost of a tank much smaller. And then by shrinking the media, the maintenance side of it is very minimal. Like I mentioned before, you could put a backwashing valve on and just backwash it and send it to drain and back into service, to where you can shrink the maintenance. If anybody's ever emptied these larger tanks out, replacing media, it's a grind. Working in the dealer space for many years, went on many ride-alongs where whether it was larger homes or commercial applications or restaurants or hotels or things of that nature, sucking out the media out of these giant tanks is is a lot of work. So shrinking the footprint significantly, can save you a lot of cost savings on that side too.
Is the G400 Plus sensitive to TOC or chlorine concentration in terms of performance or structural integrity?
TOC is the one. So I mentioned competing contaminants earlier. TOC is the one competing contaminant that we're going to want to take care of before allowing it to get to our media. And when I say that, in the 10 ppt, 10 to 15 ppt range, or ppb ppm range, talking ppt all day. The that I'd say like 10 to 15 range, you'd be fine. In that range, a lot of people are going to clean it up anyways, whether it's going to a softener, or it'll get cleaned up with if you're on city water and you're using carbon to clean up chlorine or chloramine, um, it can clean that up before reaching our media. But yes, the TOCs is the one thing you would want to clean up.
On slide 13, you compare against GAC. Was that a GAC marketed for PFAS removal specifically?
Let's go back to 13. I don't believe it was marketed specifically for PFAS, but I can confirm with that and get back with them on that. But to my knowledge, it was not.
And another one is there any aluminum leaching from your media and what is the concentration level?
No, no. No alumina. We have not seen that across the board at all. So um, I'd be interested to know if anybody ever did find that. So we have not, the extensive testing we've done, I've not heard that.
Is black back flushing generally recommended? Is this only needed for hydraulic conductivity improvement for beds that get filled with grit?
If you have depends, I guess like a lot of things in water treatment, it depends on the incoming water coming into the what would be our tank or filter or whatever type of system setup you're using. Um, Depending on how bad that water is, yeah, it's used to just flush it off and send it to drain. Um, you can set up a in and out valve on top of a tank and just have water go in the inlet and out the outlet, and treat it for PFAS that way as well. Um, the the backwashing valve is really just used to flush off the media if there was you're dealing with some rough things coming in. If you're on city water, you don't really have to. City water is you're really just dealing with chlorine or chloramine, whatever they use in the treat at the facility, and then hardness. So if you're using a softener beforehand to treat the hardness, our media is gonna be perfectly fine. You can send it in and out. It just provides you an added layer with a control valve on top to be able to flush and wash it, and extend that life of that media maybe a little bit longer than if you didn't. But either way, it's going to last a significantly long time.
You mentioned broad spectrum PFAS removal. What do you include in the broad spectrum PFAS?
Short chain and long chain. So kind of across the board, we've seen great performance across both chains. So short and long chain. Um, it's been quite remarkable how well it's performed across the broad spectrum. So that's why we use that term. Um, as I should have mentioned earlier too, with some of the data, if anyone that's on the call that we haven't had discussions with yet and wants to dive into it even further, we can absolutely do that with an NDA, and really get into kind of more nitty gritty stuff. But broad spectrum, short chain, long chain, we've seen great performance across the board. Um, I'll go ahead and preface it. PFBA it is probably the hardest one, and it's the hardest for everybody. So um, outside of that, we've seen superior performance across the board.
When do you expect to get certification for POU use?
Yeah, it's a good question. Now, personally, I'd love it tomorrow, but selfishly. But outside of that, it's probably going to be a little while. It is on our radar. It is a priority because obviously POU is drinking water as well. Um, but I can't give a timeline now. I don't think anybody on senior leadership would be able to give a timeline currently, but we will have it. We will have it eventually. I think it's safe to say that. I couldn't tell you at this current time and place.
What does media replacement frequency typically look like compared to GAC or IEX?
Uh, it's going to differ between the two, but we've seen 7x longevity compared to ion exchange and 40 or more, depending on the situation. 40x longevity compared to GAC on even more than that on some industrial stuff. So somewhere somewhere in that range, you'll see significant longevity. A lot of the products that we've been looking at, obviously we're diving more and more into the POE space now that we have the NSF 61 certification from IAPMO, um, that allows uh, that allows us to really pursue this market even further. It's kind of been a little bit of a holding pattern for a little while. And with that, we're going to, uncover, depending on how system setup is, how we want to tailor that to for change out. So I think most people are used to a 1 year change out on things, whether it's filters, your RO filters under your sink. Um, you have in Florida here, they do probably carbon change outs on homes with municipalities that are using high levels of chlorine or chloramine every 3 to 5 years. Carbons are getting changed out. So um, we look to design products in that range. And with that, if you want something to last 1 year or 3 years, we can have our engineering team and the, your company's team work on a solution to kind of tailor it for that based on what we know, especially on incoming PFAS and what the longevity is you want for your customers.
And we'll take one more question. This one is, have you looked at TFA removal? That is the ultra short chain PFAS.
Yeah, the PD team is definitely looking at ultra short chain. Um, it's a focus of theirs. Probably all I'll say on that now. It's definitely on the radar. Ultra short chain stuff is something that's a priority for the PD team to look into. So they're already diving into it, and it's a probably more to come on that in the future here.
Okay, so if there's no further questions, I'd like to thank you all again for joining us today. Thank you, Ryan, for the insightful presentation.
Thank you.
Um, if any of you would like to continue the conversation or explore collaboration opportunities, please don't hesitate to reach out. Ryan's information is on the screen. And if you have more of a general inquiry, our email is info@puraffinity.com. And we appreciate the time you all took to watch the webinar, and I wish you all a great day. Bye, everyone.
Thank you, everybody.